Once our solution is performed, now we are going to see what exactly the changes we need to go for the reduction in the output. So we need to reduce this particularly the maximum 1 MIC stress value 3426. We need it less than this particularly. So we are going to analyze for that particularly. So for the values over here. So this particular value is not having the elemental calculation only. It is having again the geometric volume considerations with respect to the geometrical entity. So we need to go for the only finite element entity calculations, and we had already defined our design parameters over here. So we can see the scalar parameters over here as a 4. So now let us close it. We need to add our 1 MIC stress values over here, and again our objective value also. The objective for this particular design is our volume. We are going to affect the volume value if we are going to disturb our radius also. So in that ways we need to go for the analysis of that particularly. So let us come out of the plot results and say element table. We can plot our element table for the 1 MIC stress value. We are knowing how to plot an element table with respect to the beam annealing. The same procedure we are adopting over here. Let us say element table. Say define the table. Define table, let us say add over here in the new pop-up window. We are going to add our table over here for the stresses. The stresses that too with respect to the 1 MIC, let's go for 1 MIC over here. So stresses in the first column, 1 MIC in the second one. By default you are getting over here once we are clicking on the 1 MIC. Now we need to define the name for this particularly. So I am going to define a name for this particular is SEQV, the equivalent stress. In that way we are going to define the shortcut or the name or user label for stresses, and let us say apply. Once we are adding over here for the 1 MIC stresses, now we should add over here for the volume value also. So when we need to go for the volume, it is a geometrical entity form. So let us click over here, say geometry. In the geometry we need to add for the elemental volume. So let us say elemental volume, and again we need to write down for the user label. So I am going to enter the user label as VOLU for the volume, and let us say OK. So in that ways we need to add for the 2 equivalent stress or 1 MIC stresses and a volume. So in that ways we are having 2 quantities, and just close it. Once we are defining for these 2, now we can see the elemental plot regarding the 1 MIC stress value. So let us say plot the element table for equivalent stress. Rather we can say it as a 1 MIC stresses and just say OK. Once we are plotting all the things with respect to the element table, now we can see the drastic change in your 1 MIC stresses value. So we are going to affect for this particularly the 2871 is our elemental table plot value for the maximum 1 MIC stresses. So I need, or the design optimization is basically we are performing for the reduction. We need the reduction in this particular stress value. We need to reduce our stress values from 2800 to 71. So we are going for this particular analysis. So let us come out of our element table. Now whatever the value with respect to the maximum stresses we are having over here, we need to go for the parameters, scalar parameters, and we need to add over here. So when we need to add over here, we need to adopt some procedure for that. So I need to add over here. It's not direct procedure to say 1 MIC and add it over here. So we need to add it over here. So let us come back over here, say list our results. In the general post processor, list results, we need to sort our results with respect to the elements over here, finite elements. So let us say sorted listing, and in the sorted listing we should say sort the element. So let us say sort our elements. We are going to sort our value in the descending order itself for a 1 MIC. There will not be any change with respect to the another input. Just keep it as it is and just say OK. Once we are sorting, that means we are sorting our elemental values for the 1 MIC stresses value. Once that particular task is performed, now we need to add that particular value in the design parameter table. Click over here in the utility menus parameters, and say get our scalar data, because we need to add our data with respect to the scalar parameters. So let us say get scalar data. Just select that one. Now we can see a new pop-up window over here. So in this particularly, now we need to add for the result stresses is our result, and we need to vary for this. So we are going to say a results data over here. Once we are going for the results data, now we need to go for the window over here. In the results data, we need to go for the other operations over here. The results data in the first window, and let us say it is the other operation over here, and then say OK. Once we are saying OK, by default we are getting a new pop-up window for get data from your post-process operations. Whatever the data we are sorting, we are going to get that particular data from the post-process operation. We are sorting for SEQV value, that means we are sorting for 1 MySys stresses value. So we are going to enter SEQV, the same name what we had already defined in our element table. We need to define the same name over here as a parameter name, or the name of a parameter to be defined. So same name we need to enter over here, and keep rest of the things as it is. We are sorting operations, and that too for the maximum stress value. So keep it as it is, just enter our name for that parameter for which we need to add it in our scalar data, and just say OK. Once we are saying OK, our value regarding this particularly Smax 2871 is added over here. Let us cross check for that one. Let us say parameters and scalar parameters, and cross check over here. We can see SEQV is added over here with respect to the given input 2170.54. So in that ways we are going to add for the stress values over here. So we are having that particular value added for the procedure what we are adopting for the design optimization. So the same procedure we need to repeat for the volume also. But before going for the volume addition, now we need to again go back over here in the element table, and in the element table, without forgetting, we must say sum of each item. Let us select that one, and whatever the procedure now we are adopting by selecting sum of each item is related to your addition of geometrical entity or the volume value over here. We had already added for the stress value. Now we need to add for the volume, so we must say sum of each item, because we are needing the volume for each and every element. That means a total elemental volume. So let us say sum of each element from your element table items, and just once we are selecting for that one, we can see our elemental volume over here as a given input over here. So manual calculation of this particularly regarding the volume, we can easily say it goes for the 1 lakh. But once we can go for the elemental volume, we can see this particular value is reduced over here as a 93,003. So in that ways we are getting the less value. That means it is having some percentage of error. We need to improve our mesh. So we need to try to get our best mesh quality to get best results. So we need to add for the volume value regarding 93,003.1 in again a parameters over here. So let us come back over here. Once we are summing for each and every item, let us go back, say list results, and again sort for the elements. Sorted listing, sort elements. Now we are sorting for the volume over here. Let us say volume and just say OK. Once our sorting with respect to the volume is over, now we need to add it. So let us come back over here in the utility menus, say get scalar data. Parameters, get scalar data. We are sorting over here for the results data. But in the results data, we need to go for the sum of each and every element table item. So we should say element table sum. Regarding each and every element, we need to go for the element table sum. So we should say results data element table sum and just say OK. Once we are saying OK, again we are having a new pop-up window by default. So we need to specify the same name what we had already defined for the volume. So let us say VOLU. We had already defined over here, and now we need to go for the change of element table item. Now we are sorting for volume from the element table data. So let us say volume and say OK. So once we are saying OK, volume value is also added over here in a parameters. So let us select that one, parameters, scalar parameters. We can see our volume also over here as a 93,003.1014. So this much of a volume of that particular plate we are going to get over here. So in that ways we are adding all the two values in this particular. So once our addition with respect to the scalar parameter is over, now we need to go for the next stage,